My full name is Silvia Danise, and I am a doctor. I am a geologist as a master's degree, and after the master's degrees I gained a PhD in paleontology at the University of Florence in Italy. MAREST means Marine Ecosystem Stability and Turnover, and this is the name of a project I've been working on for 3 years now. Project MAREST was funded by the European Union through the Marie Curie Action. In this project, I wanted to study marine life. This is why we are by the sea now. And what we wanted to understand it is how marine ecosystems change through time, but not in a short time scale, like in years of thousands of years or centuries. What we wanted to understand it is how marine life changes through hundreds of thousands to millions of years, and which are the physical aspects that produce these changes. MAREST project is organized into 3 years and into 2 parts. In 2015, I moved to the United States to work with Steve Holland at the University of Georgia. And in the first 2 years of the project, we work on a discipline that is called stratigraphic paleobiology. In stratigraphic paleobiology, we pull together sequence stratigraphy and paleoecology to better understand faunal change through time. I decided to work with Steve Holland because he is the main expert in this field, and so with him I could improve my skills in sequence stratigraphy. In these disciplines, we merge understanding how sedimentary rocks are formed and how sea level changes affect deposition of sediments, of marine sediments. And so by understanding this, we can understand also the fossil record, because in marine sediments we can find fossils of marine origin, and in understanding what are the processes that drive sedimentation, we can also understand how fossil form and fossiliferous horizon forms, and so we can understand the diversity of the fossil record. And this is one of the main objectives of my project. At the University of Plymouth, I did the second part of the project, where I analyzed the fossils that I collected in the field during the first part in Wyoming and South Dakota through geochemical methods. I did carbon and oxygen isotope analysis and also trace elements analysis to understand in which physical and chemical conditions the shells were formed. So we were able to trace changes in temperature through time, changes in salinity through time. And this is very important because we were able to understand how marine community change through time, which are the physical processes that cause the changes like sea level changes, but also if other physical factors are important, like changes in temperature and salinity through time. And we know, for instance, that global warming in our sea is a very important factor. So controlling temperature change through time, it's really important and relevant.
Beautiful.
In the project, we studied the Jurassic Sundance Seaway. It is a seaway that existed in the middle of the United States around 180 million years ago, from the middle to the upper Jurassic. And we studied many different localities at different latitudes and longitudes, and we reconstructed how marine life changed over 10 million years. In MAREST, we found that the marine communities that lived in the Sundance Seaway were affected through time by many different physical factors. We control on sea level changes, and we found that sea level change with cycles, over cycles in the seaway, and these affected mostly communities that were living in the deep sea. Every time that sea level went down in the seaway, deep water species got extinct, and with a new sea level rise, new species entered into seaway to colonize it. But this happened in the deep sea, while on shore, on a shallow sea, species were more resilient to change. And there were some species that persisted in the seaway for 10 million years. So they were not affected by sea level changes. And this is very important if we consider what can happen in the modern times, and how much changes in sea levels that happens today can affect marine species. But the second factor that was very important was the type of sediments that were deposited in the seaway. So the main turnover that occurred in the seaway was at the change between carbonate deposition in the middle Jurassic, when temperatures were higher, to a siliciclastic deposition where the weather was more humid and hot. This is the main physical aspect that caused the turnover in the seaway that happened between the middle and the upper Jurassic. But again, at the same time, deep water species were more affected to this change than onshore species and onshore communities.
Important.
I had the great opportunity of doing my PhD in Italy, then to work in the United States and work in the United Kingdom. So over my research, I could experience 3 different university systems and 3 different ways of doing research. And it takes a lot of energy to get used to new places and new cultures and new systems, but it's really worth it, because then you can understand what are the positive and the negative sides of all of these systems and take the best of those. And so I think that European Union is doing their best to promote mobility among researchers, and I think that this is great.